Right, hello there everybody. This is a quick video. This quick video I'm doing is an anti-gravity test, and just to show you what we got here, my setup. This is just a wall of my room somewhere. That's my usual free energy board. It's probably about 2 feet in diameter, 2 feet from this end all the way to that end. That's about 2 feet. Okay. Today we're not rigging up much. The only thing we're doing is well, we're using one car battery here to drive a voltage inverter here, and this one's 1500 watts. Probably won't be using more than about 400 or less, and the output of this will drive this MOT here, and the MOT will this energy will go directly through this capacitor here. Now notice this capacitor here. It's actually attached to our scale. The scale here, we're looking for a meter change in its reading. It's going to be set for 0 at this normal weight, and anything becomes lighter we'll get a reading on here. It's quite straightforward. They call it a tar setting. It's quite a good tar setting. A bit confusing, but nevertheless. But even a slight twiddle of numbering on here means we've established anti-gravity existence, and we can start dancing after that. Here we go. What else? There is a spark gap there, and there will be a tiny spark just across. Let's have a look at spark gap. Look. Let's get my finger down there. I don't want to get. Right, that's a spark gap there. You've got an aluminium tube over it, and you've got one bolt here and one bolt on the other side. You've got 3 screws there. There's a capacitor discharge areas to stop my capacitors from discharging, but forget about that part of the circuit. In fact, we don't need to worry about the rest of the circuit. All we need is a MOT with a one spark gap. And the only thing else between the spark gap is a capacitor, one capacitor here, and we actually using some diodes here. We're our diodes. Down there we've got 2 black things. You can see them. Come this side. Here they are. Yep, you can see 2 black things down there. Let's get my finger down there somewhere. Right, these 2 black things, those are 2 microwave diodes in parallel. Okay, so the energy from the it's actually a bit back to front here, but it doesn't really matter. The energy from the live wire comes from the MOT. After the MOT goes through the capacitor, out of the capacitor through the diode, out the diode through the spark gap, from the spark gap through the big coils and back to earth. But really, it's just basic. I really need to have the MOT connected to the diode, and from the diode into the capacitor when I'm doing it properly. But to do it properly, that's for another test. We've established something here, and I want you guys to see this. Right, that's enough of what we basic setup. Of course, you guys are going to go mad and ask me for the circuit as well. Okay, I'll probably have to draw up one of them. Right, now what I'm going to do is get all this lead here, because one of our leads already connected here. This one here onto the battery. This one here will be connected onto this terminal here. When I do that, the system will fire up. Okay, I'm just going to get ready for that, and let's see what happens. Right, get ready here. Just get ready here to touch that. We're not going to touch anything yet. Now we need to come over here. Whoopsie daisy. Right, let me just turn our meter on. There's our meter. We're going to let it settle into tar state, and it'll be on. It's on kilograms. Can we see from here? Yeah, we can see kilograms there. Pity about the shadowing. There we go. Kilograms. Just about see it there. Got camera shadowing on there, but now there we go. That's a nice shot. Okay. Try and get that one for you. And we know what's already on there, which is this setup here, which is connected to it. Put my hand around the back of that so you can see it's all there. Okay, and if I was to lift this up, what would happen? There's my hand. I'm going to lift this up. Can you see that? As soon as I lift it up, it measures it becoming lighter. I do that again, and we're going to hands up. There we go. Okay, it won't settle unless I'm going to have to re-establish a starting point on that. There we go. Right, it's going to settle in a minute. It's off. I'm ready to go for this test. Okay. Right, get the probe ready. Well, call it a probe. The positive lead onto battery. Remember, we're going to connect it onto here. Alright, you may see me do that, but let's get a focus on here. And we're trying to get a good focus going first. Right, that'll do it. 1, 2, 3. There we go. We got it. That flicker. That's all we needed. That is anti-gravity. Established, fully established anti-gravity takes place through any capacitor once HT's going through it. There's not much DC on that. I can get better DC connection on that. And if I turn that to naked, well, I can improve on the entire setup a lot more. But that illustrates that when electricity goes through two capacitor plates, the plates become lighter, and thus any mass on the plate also becomes lighter. This sets up the basic steps for a hoverboard and just about anything else, including your flying saucer engine, you name it, Anunnaki Black Battle Station near Aruba. Okay, well, I'm so happy now. We can go dancing because we've now established anti-gravity exists. Let's try it one more time. Just show you it wasn't a fluke. Got my red lead here to connect there, right? And then we got up here, monitor it. And we're going to connect again and wait for that flicker of the meter. After 3, 1. Uh-oh. The meter is timed out on power supply. Let's turn that back on. Wait for it to settle. Alright, the meter went into auto power off. Right, here we go. We should be ready now. Let's try it. After 3, 1, 2, and 3. There she is. That little flash. That's all we need. Anti-gravity peak. End of test procedure. Keep on dancing. Anti-gravity is now established for hoverboard, warp travel, it's all flying saucers, and black battle station Naruba. Okay, I'm out of here for now.